Okay. Next topic is measures of dispersion. So knowing the measures of central tendency. See, central tendency is nothing but the central value you have given in us. So the average is kind of your central value. The median also middle value. The mode is the popular value, most popular value, most frequent occurring value. Knowing only these measures are not helpful in all the situations. Right? There are cases where use the you need to use more than these three measures to gain more insight. Okay. So, or in simple term, not all the situation, these three measures like mean, median, mode, or helpful. There are cases we need to go extra mile to use some other measures to gain more insights about your data. That's when the measures of dispersion is playing a crucial role. So, okay, so what we will do is we'll explore what exactly the measure of dispersion and its importance in data analysis. And then we'll move ahead and explore the different measures that falls under the measures of dispersion, the range, standard deviation, coefficient of variation. These are the measures, okay? Next one is we'll explore percentile and IQR, okay? So you must have heard about this term percentile. It's not percent. Percentile is different from percent, okay? And IQR. IQR stands for interquartile range. Okay, fine. So to start with, let us understand what exactly the measures of dispersion. How spread out the given data set is. That is what your measures of dispersion is all about. How spread out your data. One second. I just my stylus pen have some issues, connection issue. See something like the dispersion. I'm talking about dispersion. For example, you have something like this. Okay, you have values 10 to 20. Okay, this is the spread of your data, right? This is the spread of your data. For example, I have 10 to 50 is there or 60 is there. Okay, what is the spread of this data? The spread of the data is too wide compared to the previous data, right? So the spread of the data is too wide. So here 10 to 20, hence the spread is only this much. Here the value I have is between 10 to 60. It's the spread is too wide compared to the previous one. Okay. So that is what we are trying to understand as part of the uh, things. Okay. But why should I learn about measures of dispersion? That's a good question. Okay. Look at this picture here, the image. You have plotted when you have plotted that data set A, you get something like this. This is called normal curve or bell curve. Okay. And another data set, you plotted the data in histogram, you get something like this. Another data set, you plotted that using a histogram, you get something like this. So you have three data sets, A, B, C, when you plotted it in histogram. So I think most of you are unaware of histogram because you might have used the bar chart, column chart, not the histogram. You just think about the bar chart without space. If you don't leave space in your bar chart, what will happen? You that's kind of your histogram. So when you plotted the data in histogram, you can see that data set A is normal curve. The width is, the spread is not much. When you plotted the data set B, the spread is little bit wider than your data set A. When you plotted the data set C, the spread is too wide compared to the remaining two data sets. That's why I put the data set as a closer spread and data set C as a wider spread. Central tendency describes the center of the data, but it does not tell us anything about the spread of the data. Correct. This is the bottom line. With the help of the mean median mode, we can understand the center of the data, but it does not know about this better. This is an important question. This is what Priya is asking about it. One second. Why should I know about the spread of the data? So, how does it matter? For example, I just take one simple example. Let's say in a village, you have your own shop, right? You have a grocery shop. You have a grocery shop. And in that village, maybe right 400 or 500 households are there, families. 500 households are there. All the households, most of the households, they buy from your shop only because there are no other grocery shops are there in your village. But there are few households, they don't buy it all the time in your grocery shop because they may go to the nearby town for job or some other purpose, or every once in a week they go and buy it from there and then they will keep it in their house. Okay? But majority of the households in that village, they buy it from your shop. You are, so you at one point you find it, you are bullish. That means you are so rich, because all the people are coming and buying it from your shop. You don't have any competitor. Now, customers are so happy and you are happy, and your profit is going up, your revenue is going up. So what you decide at one point in time, you want to set up a shop in a nearby village. In a nearby village. Okay, in a nearby village. So what you do is for that, you wanted to, so you just planned a date and you started going to that, you're planning to go to the nearby village to conduct the market research or market study. You are going by, the specific person, right? This shop owner, the grocery shop owner. So he wants to go to the nearby village to conduct the market study. So based on the study, they want to decide whether is it worthwhile setting up a shop in the nearby village or not. Okay. So what they do is they decided to go by walk. So this guy takes another guy. Maybe he's a data scientist. Okay. So both of them, their height. So 5.4 feet only, both the guys. Okay. And they carry a laptop. Carry a laptop. So what they do is, right, to go to the nearby village, they have to cross a river. Cross a river. So to cross a river, what happens? People, they are just standing. Not, is it true depth? So what happens? The shop owner, right? This guy calls one passerby. One guy is going that side. He calls him, hey, can you tell me, hey guy, can you tell me what is the average depth of the river? What is the average depth? 5 point. This is the average. Or in statistics, we call it the mean. So 5.2 feet. So with this data, this is the average depth of the river. Which is nothing but the mean, okay? Average depth of the river, or the mean depth of the river is 5.2. Okay. So can you, based on the average or the mean, it's nothing but central tendency, can you decide to go by walk to cross the river? Because both the guys are not taller and they carry a lap, both of them are carrying their laptops. Okay. If the river depth is more, what will happen? Both of them may get drenched and even the laptop also will get drenched. They want to be diligent. So what happens? The shop owner says the average depth of the river based on the information which he sought from the guy, right? Which he got it from the guy. He decided to cross the river, but the data scientist he say, hey, no, wait. He calls that guy again, the passerby. Hey, average depth of the river is fine. Can you tell me, let's say, every 15 feet or every 20 feet, what is the depth? Now he gives some information. Initially it's 2 point some. If you after 20 feet, just 2 feet only, and 2.5 feet, and 3 feet, and 4 feet, and somewhere 4.2 feet, and again he says again it will be 4 feet, and then every 20 feet. First 20 feet they will find 2 feet depth and then the next 20 feet you will have find the depth is 2.5 and in somewhere it is going to be 6 feet. What happens now? So when you take the average, just because you have more smaller values, because an outlier is there, right? More smaller values, what will happen is you get the average 5.2. But after talking to him, now you decided, no man, there's no way we can cross the river by walk. We need a boat. Because somewhere the depth is 6 feet. Now you can see the spread of this data is too wide, right? This is too wide. This is spread. So by understanding that means more the spread, more the volatility. Somewhere it is 2, and somewhere it is 2.5, and somewhere he says, 1 also. Okay, somewhere he says 1 feet is there. Somewhere he says, after you cross the, 1 furlong, he says, it's going to be 1.5 feet only. So, initially you're tempted to think, hey, we'll go by walkman. Why should I, hire a boat? But after seeing that, the data is too volatile. Somewhere it is 1, some on the other hand, we can see the 6 feet. Outlier is there. So better let us go by a river instead of going by feet. Okay. So now with this simple story, you understood knowing the average alone not sufficient. Knowing the spread is also very much important. The spread, more the spread. So obviously the river by walk. So knowing average alone not sufficient. Not all the time you can gain insight by applying the measures of standard tendency. There are situations you need to know the measures like dispersion. That one will help you to understand we have an outlier or something else. So to start with, let's explore the measure called range. Range falls under measures of dispersion. So the range, it quantify the dispersion. With the help of the range, we can understand how spread out the data is. Okay. What is the formula for range? Are there any formula? Is it yes? Take the maximum value from a data set and subtract the minimum value from it. That is what your range. Got it? Take the maximum value from data set and find out the minimum value. Subtract the minimum value from maximum value. That is what your range. Okay, what are the limitations of range? Range is sensitive to outliers, man. Range is sensitive to outliers. It ignores the intermediate values. It lacks the distribution information. Range is sensitive to outliers. It ignores the intermediate values, lacks the distribution information. So what do you mean by range is sensitive to outliers? Let's take some sample data. Let's say in a test, right? You are taking up a same test on a different time period. Let's say on a Monday you took the quiz test. You scored 40, and Wednesday you take the same quiz. You scored 89, and so on. Okay, different days, your score you note it down. So here, if I compute the range, what the range value here? Maximum value is 100, but the minimum value 40. 100 minus 40 is 60. Okay, 100 minus 40 is 60. Fine. So here the 40 is the outlier. If you remove the 40, what is the range? 100 minus 89. 100 minus 89, how much? 11 only, right? But if you take into account of the outlier 40 in this case, 100, which it shows 60, higher the range value tells us more the spread. Okay, more the spread. So lesser the range value, that tells us lesser the spread. Simple example is if you exclude 40 here, you are left with 89 and so on, right, till the 100. If you compute the range, 100 minus 89 is 11 only. So since the 11 is smaller number, we can tell the spread is less. The spread is less. Okay. And if you include the outlier 40, 100 minus 40 is 60 years, the spread is, it will help, it make you to think, oh, 60 is a big number, man. So too much of volatility is there. So that's why I told you range is sensitive to outlier. It ignores the intermediate values. Like a mean, so unlike mean, right? So mean, in the case of mean, it takes into account of each and every value. But here, it doesn't care about all the values. It cares only about the maximum value and the minimum value. That's all, right? Take the maximum value, subtract the minimum value from the maximum, you will get the range. Next one is the lack of distribution information. So here there is no distribution. Only when you plot all the data, you will get to know the distribution. Here there is no distribution information you can get it. So this is a limitation with the range. Okay, what kind of scenario that I can use the range here? Look here, you have two production units are there. You produce TVs. You are a TV manufacturer. South Chennai, North Chennai, you have two different manufacturing units are there. The first one is South Chennai and this is North Chennai. So between 48 to 52, the spread is very less, right? There is no volatility. So the 48 TVs they manufactured and 49, they manufactured this one and 50, even 52. This is the spread is between between 48 to 52. They produce it. The range is 52 minus 40, only 4. Okay, the spread is very less here. But if you see here in the north region, right? North Chennai, some days they produce 40 and then the remaining days they're idle. And sometimes they produce 47 and another day 50, 53 and they are idle and suddenly 60. So here the maximum is 50, but here the maximum value is 60. And if you subtract the maximum value from the minimum value, 60 minus 40 is 20. Whereas here just 4, it is 20. Hence the spread is too high. Since the range value is high, the spread is also too high. With this, what you can infer, here a lot of inconsistency are there, right? Sometimes, someday they produce 40 and then they did not do anything. And again, so there is some productivity issues. Okay, with that you can understand a range. Hey man, there are some productivity related issues. Probably we can cut down the daily wages also. We are paying, we hired more people than required, right? So hence probably we can scale down the staffs or the daily wages. Or is there anything can I do to improve the productivity, right? So this is called a distribution, data distribution. How spread out. Here the spread is less, if the spread is too wide, right? So this is the data distribution. Range can help you to understand the distribution with the single number called range, right? So maximum minus minimum will get the range. Higher the range value tells you quickly the spread is too wide. The spread is too wide. Lesser the range, it tells you the spread is very less. Good. But just because you have an outlier, for example, 60 is an outlier. Okay, just because of that, makes you to think It is too wide, right? 60 minus 40 is 20. Okay. Just because you have an outlier here, it makes you to think it's too wide. The spread is too wide. If we exclude 60, what will happen? So 40 to 53, right? 40 to 53. 53 minus 40, 13. The spread is less. So because of the this measure range is sensitive to outlier, makes us to think, hey, it is too wide. The same thing is applicable here also. The exam scores. Look here, if you exclude 40, your range values with just 11, right? Makes you to think, hey, the spread is less. But just because one outlier, so lot of inconsistency are there in my data. You might tend to think like that. The same thing is applicable here. If you see, right, if you exclude the 60 watt to 11, almost these are closer, right? Including this one, somehow closer. So these are closer. Maybe, maybe this one is outlier, remove the two outlier. So these values are somewhat closer. It's fine. So the range is sensitive outlier. We cannot literally go by the range. Like I said, just because I scored just 14, only one quiz, rest of them I scored more, it makes the person to the judge, it makes the judge to think, hey, the range is too wide. This person is not scoring consistently. Got it? Fine. Okay, guys, since this weekend, lot of things happened, a lot of confusions happened.